3.2b, we're going to look at P represents it is raining. Q, there are clouds in the sky. Well, just like we have negation in sets and in probability, we have that as well here too in logic. This means not P. So how would we word this right here? We'd say it is not raining. And if we had not Q, then we would say there are no clouds in the sky. Okay, very good. So if we have something like this, not P and Q, how would we word that? Well, we know what not P is. It is not raining because P is it is raining. So not P is it is not raining. It is not raining. And then we have this and Q. And Q is there are clouds in the sky. So we say and there are clouds in the sky. Okay, very good. All right, what if we said this? P or not Q? P or not Q? It is raining, that's P. It is raining. Or not Q. Q is there are clouds in the sky, so not Q, there are no clouds in the sky. Or there are no clouds in the sky. Okay, so let's keep going. We also have an if P then Q. Let me write that down. So this P with an arrow, this means if P then Q. All right, so let's do the example with the same ones we did. It is raining, there are clouds in the sky. So we would write, if it is raining, then there are clouds in the sky. Okay? Let's go back to the working at 5 p.m. Let's look at not Q, then P. So if you look at the notes, what was Q? Q was they are working, and P was it is after 5. So right here we have it is not working. Okay? If they are not working. So here's our if-then statement. If they are not working, then it is after 5 p.m. Okay, very good. Just like we have if-then, we also have if and only if. If and only if can go both ways. They must be a true statement both ways, okay? So, the symbol for if and only if is arrows going in both directions. We can say this is if and only if. That is the symbol for this, if and only if. How we would word this, we would say P if and only if Q. Okay? So let's give you an example, something that's more concrete. Let P equal the statement 1 plus 2 equals 3. And let Q equal 2 plus 1 equals 3. Can we say P if and only if Q? Of course we can. We can say 1 plus 2 equals 3 if and only if 2 plus 1 equals 3. Okay. Let's do another one. Let P equal a person is an unmarried male. A person is an unmarried male. If we say a person, I'm going to say the person. The person is an unmarried male. That's better. Q. All right. The person is a bachelor. Okay. So can we say P if and only if Q in this situation? Sure we can. If the person is an unmarried male, if the person is an unmarried male, actually I'm going to go the other way. The person is an unmarried male if and only if the person is a bachelor. Okay, let's do one more problem and then I'll give you your homework for this section. All right, so let's say P represents the statement she is 7, meaning 7 years old, and Q, she is tall. What would this represent? What would that represent? Well, let's start off with the parentheses. This statement is P and Q, which is she is 7 and she is tall. So let's write that. She is 7 and she is tall. Okay, and then we put this negation in front of it. So how can we word that? Well, there's different ways of wording it. Here's one way. It is not true. She is 7 and she is tall. Okay, so here's your homework for this section. One through 21, odd. 27 through 31, odd. 49 through 57, that's a 7 right there, odd. And then 67.